In this section, we're going to focus on component design patterns. I've decided to make this topic into a separate section. It won't be part of the past two projects we've worked on. It's because component design can become very complicated. Not every design pattern will be suitable for every project. So first of all, what is a design pattern? You may have heard that word frequently throughout your development career. A design pattern is a general, repeatable solution to a commonly occurring problem in software development. As developers, one thing we want to avoid is having to repeat writing the same code. One way to avoid this is to make a function or class that's generic as possible. This way, we can drop it into different code bases to reuse it. One of the main advantages of learning design patterns is that they're not tied to a specific problem. The main goal is to create a solution that can cover various problems in most projects. We'll be looking at design patterns in isolation from everything. This way, we can better focus on the design pattern. After you've finished with this section, you're more than free to take what you've learned and apply them to past projects. When you're ready, I'll see you in the next lecture. In this lecture, we're going to learn about controlled components. Controlled components are a design pattern for forms. In some situations, you may end up creating an input with special interactivity attached to it. You may want to reuse the input for other forms. This situation is where the controlled component design pattern may work for you. What exactly are controlled components? It's a component that outputs an input for a form. The input can be anything like a text box, checkbox, radio button, or anything else that can be used in a form. What sets it apart is that the component doesn't have its own state. It's not meant to be controlled from within. Instead, it relies on the parent component to supply it with data. The data from the parent component is what gets rendered as the value for the input. If the user attempts to change the input, the component will emit an event. The parent component will be able to update its state and pass down the changes to the child component. This pattern keeps the child component dependent on the parent component. This is why it's called a controlled component. It's a component that is controlled by the parent component. Let's look at an example. In the resource section of this lecture, I provide some starter files in a zip file. Take a moment to upload the files anywhere on your machine. Once you've got it installed, start the development server. Pause the video to get this ready. Here's what the project will look like when you open it in the browser. It's a simple form with two input fields. There's an input field for the name and another for the email. The name input is simple in nature. On the other hand, the email input is much more interactive. If we were to type into the input, the surrounding border changes to red. It's validating the input. The validation will be successful if the email is longer than 4 characters. We can type in 4 characters to see the border change to green. The form data doesn't get submitted to a backend. It'll get logged in the console. In the Chrome Developer Tools, we'll inspect the console. If we were to submit the form, the data gets logged. Let's open the application in the editor. I've added Bootstrap to help us with some styles. A lot of the files remain unchanged from the default setup. We'll be focusing on the app component. In this component, we have a lot of HTML and classes, but we won't have to worry about them. A lot of it is to mainly help us position the form. The form is where the magic is happening. On the form element, we're listening to the submit event. If it's triggered, we'll call a function called submit. Next, we have 2 input fields. The first input field has the vModel directive attached to it. It's bound to a property called newsletter name. The second input is bound to a property called newsletter email. In addition, the class attribute has property binding. We're using the object syntax to toggle 2 classes. They're the isValid and isInvalid classes. This will apply the green and red borders, respectively. The conditions we're using to check if the email's character length is equal to or greater than 4. If it is, we'll add the green border. Otherwise, it'll get the red border. Both conditions will check if the length is greater than 0 because we don't want to validate an empty input. In a real scenario, there are additional checks we'll want to perform. For demonstration purposes, we'll keep it simple by checking the length of the property. There's not much else to go over in the template. Scrolling down to the script block, we'll find the properties and methods that are used in the template. Initially, the newsletter name and newsletter email properties will be set to an empty string. In the Methods option, we have the Submit function. We're logging the properties in the console. The last thing we have is the Style block. Instead of directly adding the styles, we're loading the Bootstrap styles using the Source attribute. This is an alternative solution for loading CSS in a component. The Source attribute can be set to a path for where the CSS for a component can be found. Alright, let's create a controlled component. We're going to convert the input for the email to a controlled component. An email is a common field for a lot of forms. It's perfectly reasonable to assume we'll need to validate an email in every situation. Therefore, we'll move the input into a separate component. We want the component to be reusable. In the Components directory, create a file called emailinput.view. In the newly created component file, we'll scaffold the template and script blocks. The name option for the component will be set to email input. It's considered good practice to use multi-worded component names to prevent collisions with future HTML elements. Next, we'll move the input. Back in the app component file, we'll cut the input for the email. Paste this into the email input components template. The component will not work because the vModel directive is bound to a property called newsletter email. We'll define the data function for the component. We'll add a property called value. It'll be set to an empty string. The component we're creating will be used in multiple forms. The property name we were using previously is too specific. We want to treat the component as if it were generic. The property names in the component should be generic. We'll need to update the template to use the value property instead of the newsletter email property. The component is ready. The next step is to load the component in the app component. Back over to the app component, we'll import the email input component. We can register the component by adding the Components option. The last step is to use the component. In the template block, we'll load the email input component where we previously cut the input. We'll test the app in the browser. Back in the browser, we'll see the same input appear. We can begin typing in the input to check if it behaves the same way it did last time. The red border will appear if the email is less than 4 characters. It'll change to green once we meet the minimum threshold. That's great, but there is one problem. If we were to submit the form, the object in the console would still get logged. However, the property that holds the email remains an empty string even if the input has a value. This is because the component state is not accessible in the parent component. It doesn't send the data back to the parent component where the form submission occurs. This situation is where the controlled component design pattern can help us. To better understand what we'll want to do, let's explore the vModel directive. Back in the editor, we're using the vModel directive on the input for the name. The vModel directive is syntactic sugar. It does 2 things to an input. First, it binds a property to the input's value. Secondly, it listens for changes. Let's replicate the behavior of the vModel directive on the input. We'll replace the vModel directive with the value attribute. The value attribute is where we can set the value for the input. We'll bind it to the newsletter name property. View will update the value attribute whenever the property changes in the application. The vModel directive does another thing for us. If the user types in the input, it'll update the respective property bound to the input. We can replicate this behavior by listening to the input event. In the event, we'll update the newsletter name property to the event.target.value property. The code we've written to replace the vModel directive will do the same thing the vModel directive did for us. Let's try testing if this works. Back in the browser, switch to the View Developer Tools. We'll want to inspect the data for the app component. The value for the newsletter name property is an empty string. The input for the name reflects that. If we begin typing in the input, the component's data is reflected with those changes. It's reactive, the same as vice versa. We can use the tools to change the data in the component internally. Changing the data in the component will update the input. This is how the vModel directive works. The app component is controlling the input. In a way, it's a controlled component even though it's not wrapped in a component file. We're controlling the state of the input by using two directives. The way we're controlling it can be applied to our components. Back in the editor, we'll update how we're using the email input component in the app component. On the email input component, we'll add the vModel directive to it. We'll bind it to the newsletter email data property. The vModel directive doesn't need to be put on HTML form elements. We can use it on regular elements or custom components. If we use it on anything else besides a form input, the vModel directive will behave slightly differently. Make a copy of the email input component below. The vModel directive will bind a property called model value to the element we're adding it. The value for the property is bound to the value we passed into the vModel directive. In this example, it would be the newsletter email property. In addition, the vModel directive will listen to a different event for changing the property. It'll listen for an event called update::model value. In the event, it'll update the newsletter email property to the event object. Behind the scenes, these bindings are what the vModel directive will apply to our components. We can use this knowledge to update the behavior of the child component. We'll comment out the second copy of the component. The first one is simpler to read. Let's switch over to the email input component. We'll update it to use the bindings the vModel directive applies to it. The first thing we'll do is completely remove the data function from the component. We don't need to keep track of the value property in the data object anymore. It's going to be provided by the parent component. It'll be replaced with the props option where we'll accept the model value prop. In the template, we'll update the template to use the model value prop. This solution may work, but this will cause an issue. To understand why, let's go back to the browser to test if this works. By filling out the email input, View will throw an error at us. It's telling us we shouldn't mutate a prop because props are meant to be sent down from parent to child. The child component shouldn't be able to update the prop. It's a rule for using props. Let's go back to the editor. Back in the email input component, we can't use the vModel directive on the input because it'll attempt to change the prop. We'll replace it with the value attribute. We'll bind it to the model value prop. The binding will set the value attribute, but will not communicate the changes. However, we want to send the input to the parent component so that it can be stored for the form submission. We know that the parent component is listening for an event on the email input component called updateModelValue. In this event, the vModel directive will update the property the child component is bound to. We need to emit this event if we want the data to be updated. We'll add the input event listener to the input element. If it's triggered, we'll call a function called update with the event object passed in. We'll define the methods option in the component with the update function. In the function, we'll call the this.emit function. The emit function allows us to emit an event programmatically. The parent component will be able to listen to the event. This is how we'll communicate the value to the parent. It has two arguments. The first is the name of the event. We'll emit the update model value event. The second argument is the data we'd like to provide. This argument is optional. We'll send the event.target.value property. We're emitting the value of the input. Here's a rundown of what's going on. The component doesn't have a state. It relies on the parent component to provide it with data. If the component experiences changes, it won't handle updating the data. Instead, it'll send the data back up to the parent component. The parent component is responsible for handling the data change. If the parent component decides to accept the changes, those changes will be sent back down to the child component. In this case, it would be the email input component. If the parent component rejects the changes, nothing will happen. Back over to the app component, we don't need to make adjustments to how we're writing the component because the vModel directive will handle everything. The child component must be updated to use the correct bindings and emit specific events. We're treating the component as if it were an input. We'll test this component in the browser. In the browser, try updating the input. According to the developer tools, the properties in the app component are updated whenever we update the input. Let's try submitting the form. Under the console panel, the object contains the value from the input. We've successfully created a controlled component. It's a component that outputs an input. It doesn't have its own state. Instead, the parent component supplies the state to the child component. A controlled component doesn't update its input. Instead, it tells the parent component when a change occurs. The parent component is responsible for updating the state. The controlled component design pattern is commonly used for form inputs that have special behavior attached to them. This behavior allows us to reuse the input in any form. The email input component is very generic. It isn't tied to the form. There's one last thing I want to go over before we end the lecture. We have the option of overriding the names in the controlled component. Back in the editor, we'll modify the email input component. We're using the name model value in the component. By default, we have to use these names. We can change the names by adding a directive argument to the vModel directive. Back in the app component, we'll add an argument called email to the vModel directive. The vModel directive will behave the same way as before. The main difference is that it'll use a different name for binding properties. Instead of using model value as the name, it'll use the name we added as an argument. The argument value can be any name we want. Let's update the child component to reflect these changes. In the email input component, we'll change the word model value to email. The purpose of doing this is to give us more flexibility and readability in our controlled components. The names are much more descriptive to the component, yet still broad enough to understand this component is not tied to a specific form. We can even add multiple vModel directives to a single component if we use the argument to change the default name used in components. In this lecture, we're going to refactor our project. Before we do, we need to discuss a concept called separation of concerns. It's a design pattern for deciding how we should architect an application. Let's say we need to switch UI frameworks. At the moment, we're using Bootstrap. What if we wanted to switch to Tailwind? Completely rewriting an application can take up a lot of time. It can cost a lot of money too. One question you should ask yourself is how much code can you reuse? If your code can be dropped in any project, you have highly reusable code regardless of the framework. The question is, how do we achieve reusable code? Separation of concerns is a principle for deciding how code should be split. If we think about it, There are two types of logic in an application. There's UI and business logic. In this instance, UI logic refers to the code inside the template block of a component. For example, the v-for, v-if, and v-bind directives are examples of UI logic. Business logic refers to the code that handles the data in your application. By categorizing our code, we'll be able to separate them. This is the idea of separation of concerns. It's a principle for splitting logic. Code for handling UI should be separated from code for handling business logic. By dividing our code, we'll be able to change one without affecting the other. If we decide to switch frameworks, we'll be able to reuse a lot of our code, thus saving time and money. Let's apply this design pattern to our code base. We'll continue working on the Controlled Components project. Open the Email Input component file. We have a basic template. On the input element, we're binding the class attribute. The classes we're applying will change the border of the element to green or red. We're using similar conditions for both classes. This part of the code can be considered business logic. Checking if an email is valid doesn't necessarily have to be tied to the UI. It can be a task used outside the template. If we were to change templates, it's very likely the condition will not change. Maybe the elements and classes will get changed, but not the condition itself. As it stands, this part of the code is not reusable. It's not separate from the template. Everything would get replaced. This situation is where separation of concerns can be applied. We're going to outsource the condition into a separate file. In the source directory, create a file called validateemail.js. We're going to export a function called validateemail under the default namespace. This function should be reusable. We'll add a parameter called email. Whenever this function gets called, it should be supplied the email. It won't retrieve the email from an external source. The function should return a Boolean value. It'll return true if the email is valid. We can reuse the condition we had in the template. Back in the email input component, we're going to cut the condition for the isValid class. Next, we'll paste this condition as the return value for the function. Our function is ready. Let's load this function in the app component. In the email input component, import the validate email function. Afterward, we'll add this function to the methods option. Lastly, we need to update our conditions in the template. For the isValid class, we'll set the condition to the function. The isInvalid class will check if the function returns false. Fantastic! We're finished. We've separated the UI logic and the business logic. By itself, the component doesn't know how to validate an email. It just renders the template. The logic for validating an email is in a separate file. If we were to change frameworks, we never have to change the validate email file. In fact, we can most likely keep it when switching frameworks. At the end of the day, the validate email function is pure JavaScript. It's framework agnostic. This is the beauty of separation of concerns. By decoupling the UI and business logic, we can apply changes to either one without affecting the other. This won't always be true, but it decreases the likelihood of it happening. We'll continue learning about design patterns in the next lecture. I'll see you there. In this lecture, we're going to use our knowledge of controlled components to create a reusable component out of a third-party library. There will be cases where you'll want to use a third-party library in your app that doesn't support Vue. It's probably written in vanilla JavaScript or jQuery. This will mean you'll have to convert it into a Vue component manually. The best and easiest way is to convert it into a controlled component. Once it's a controlled component, we'll be able to use it multiple times across various projects. For this example, we'll be using a library called EmojiButton. It's a library for selecting emojis. We can use it to fill in an input field. In the resource section of this lecture, I provide a link to the library. We'll find a demo to see how it works. It's a simple widget. We have a button we can click to open a selection of emojis. Something like this can be useful as an input. If we scroll to the bottom, we'll find an example of installing and using the library. We'll be doing something similar to what is documented on this page. Let's get started. The first thing you'll need to do is download the starter files. You'll find a zip file in the resource section of this lecture. Upload the files anywhere on your system and install its dependencies. Pause the video if you need to. Here's what the project will look like. We're using Bootstrap to help us position things. There's one input with a button. We'll make this button clickable to open the selection of emojis. The input is not modifiable. It's set to read only. Next, let's open the project in the editor. Most of the files are from the default preset. The changes I've applied beforehand were made to the app component file in the source directory. In this file, we have the form where we're listening to the submit event. If it's triggered, we'll call a function called submit. Lastly, we have the input. It doesn't have anything attached to it. In the script block, not much is going on. We have the submit method, which will log the emoji data property. The emoji data property is set to an empty string. We aren't using it in the template. That's something we'll hook up in a moment. We are going to convert the emoji input into a controlled component. This is where things will get tricky because the library has a completely different API from Vue. We'll need to convert it into a Vue-compatible component. In the components directory, create a file called emojiinput.vue. We'll scaffold the file with the template and script blocks. It's considered good practice to give the component a name. We'll set the name option to emoji input. We can grab the template from the app component. Search for the div tag with the class input group. It's surrounding the input and button elements. We'll cut this element from the app component. We'll paste it into the template block of the emoji input component. Next, we'll import the emoji input component into the app component. Then, we'll register it in the app component by adding the components option. Lastly, we can use the emoji input component. Back in the form, we'll load the component where we previously cut the input and button. Let's check out the page in the browser. If we did everything right, we will see everything remain the same. We've successfully outsourced the input into a separate component. We'll want to make it functional by using the library. The library will need to be installed as a dependency if we're going to use it. Open the command line. If the server is running, turn it off. Next, run the following command: npm i @joe /emoji button. Next, start the server again. Lastly, open the app component. We're going to quickly bind the emoji data property to the emoji input component by using the vModel directive. The directive will do two things. It'll add a prop to the component called model value. Remember, a controlled component doesn't have a state. Its data will come from the parent component. In this case, it would be the emoji data property from the app component. The second thing it'll do is listen for the update model value event. It'll use the value emitted from the component to update the emoji data property. It's important we send the emoji back up to the parent component by emitting an event. Let's get started on making the component functional. In the emoji input component, we'll need to import the emoji button object from the package. The path to the package is @joeattardi/emoji button. This package will expose the methods necessary for rendering the emoji box. We'll be using it in a moment. First, we should accept the model value prop from the parent component. Add the props option to the component. In the array, add the model value prop. There are two locations where we'll be using the model value prop. In the template, we have an input that's set to read only. We'll want to update the value of the input with the emoji. We'll bind the value attribute to the model value prop. The model value prop will be set to the emoji selected by the user. When we use the library will store the emoji in an object. If we want to access the emoji, we'll need to access a property called emoji. The second location where we'll render the emoji is in the button's inner text. However, there is a problem. Initially, the model value prop will be an empty string because the parent component sets it to an empty string. We don't want the button to be empty when it gets rendered. We can fix this problem with a ternary operator. In the button, we'll add an expression that has the following: model value question mark model value dot emoji colon select. This expression will make sure the button is never empty. We can move on to instantiating the picker. The picker will appear below the button. That's where we'll place it. The picker won't be able to position itself unless the component has been mounted. We must instantiate the picker after it's been mounted. The mounted phase is when the component's template is inserted into the document. We'll add the mounted lifecycle function to the component. Inside the function, we'll define a variable called picker. Its value will be a new instance of the emoji button object. This new instance will create the picker. The next step is to listen for when an emoji is selected. The picker will emit an event that we can listen to. Using the picker object, we'll call the on function to listen for an event called emoji. In the arrow function, we'll be provided a value called emoji. We'll accept it in the function. In the function, we'll emit an event because we want the parent component to handle the value. Call the thisEmit function. The name of the event we'll emit will be called updateModelValue. It's the name of the argument the vModel directive is listening for. We'll send the emoji argument we were given. We're almost finished. The last thing we'll do is render the picker. Creating a new instance of the picker will not display it on the page. It'll prepare it for it to be rendered. We only want to render the picker if the button was clicked. The problem is we can't use the vOn directive on the button to listen for the event. The instance of the picker is only accessible in the mounted lifecycle function. We can resolve this issue by using refs. Refs are another way of selecting elements in a component. In the template, we'll add a ref to the button. We'll call the button emojibtn. Back in the mounted function, we'll store the ref in a variable called btn. Its value will be this.refs.emojibtn. The ref will give us access to the native DOM JavaScript API. We can use it to listen to events on the button. At the end of the function, we'll call the addEventListener function to listen to the click event. In the callback function, we can render the picker by using the picker.togglePicker function. The togglePicker function has one argument, which is the element it should appear next to. We'll pass him the btn ref restored. We're finished. Let's give things a test. Refresh the page in the browser. The input will remain empty and the button will say select. Open the View Developer Tools to check the data of the app component. The emoji data property is an empty string. Let's select an emoji. After selecting an emoji, the data property is updated to the emoji we selected. To double check, let's submit the form. In the Developer Tools, we'll switch to the console. The form is able to log the emoji without a problem. Great! We've successfully ported the library into a controlled component. There's one last adjustment we'll make. In the resource section of this lecture, I provide a link to the API options page for the plugin. This page documents the options we can use with the picker. Scroll down to the section called API. These are all the options we can use with the picker. Search for the option called position. The description says, the position to display the picker relative to the reference element. This is the option we'll want to set. The value, bottom, will position the picker below the button, which is where we want it. We're going to support every option in the plugin. Currently, we want to change the position, but in the future, we may want to configure other options. It would be best if we can allow for any of the options to be modified. We'll be using props to modify the options. We're not limited to the v-model directive. We can update the controlled component to accept an object of options which will pass onto the new instance of the emoji picker. Back in the editor, we're going to update the props option for the emoji input component. Instead of an array of props, we'll use an object. The object syntax can be used to fine-tune the props that can be used with the component. We'll add the model value prop back in. Its value must be an object. In the object, we can specify additional options for the prop. For example, we can set the required property to true. This property will make it required for the parent component to provide a value prop. By default, this is false. We'll add another prop called options. We're not going to make the options prop required. However, we'll set a default value in case the developer doesn't provide the options prop. We'll add a property called default. This must be a function that returns the default value. We'll return an empty object. The options prop will be passed onto the new instance of the emoji button. This will allow us to modify any of the options in the parent component. In most cases, you will want to filter the options. It's safer to validate the options before using them. For this demonstration, we won't be doing that for the sake of simplicity. Let's go back to the app component. We'll bind the options property on the emoji input component. It'll be set to an object. We wanted to change the position of the picker. Let's check if the picker is positioned correctly in the browser. Great! Its behavior can be modified by the parent component. This is another example of how we can use the controlled component design pattern to create flexible and reusable components. In this lecture, we're going to take the modal component a step further. We found ourselves in a situation where we decided not to use Vue's event system to toggle the modal's visibility. We're going to be doing something similar to the previous lecture. Another feature we might want to implement is to disable scrolling. Let me show you what I mean. In the resource section of this lecture, I provide a link to a lorem ipsum generator. This is a tool for generating dummy text. We'll use it to add some content to our app. Click the Generate button to generate some dummy content. Copy the text it generates. Back in the editor, we'll open the app component file. We'll add some paragraph tags below and above the button with the text we copied. Let's view the application in the browser. We'll be able to scroll around the page because of the content we added. If we were to open the modal, we'd still be able to scroll around the page. There aren't rules for how modals should behave. Some apps allow the user to scroll around with the modal open. Others disable the scroll bar. We'll add an option where we can disable the scroll bar on a whim. There are two ways we can handle this. We can disable the scroll bar from the app component. We have a property called show we can use to tell when to disable the scroll bar. The second way is to disable the scroll bar from the modal component. We'll be going with the second approach. The reason is because disabling the scroll bar should be the job of the modal component. It doesn't make much sense for the app component to disable the scroll bar. The scroll behavior is based on whether the modal component is visible. Therefore, the responsibility of handling the scroll bar should be done in the modal component. Another reason is that it makes the modal component reusable. It wouldn't be reusable if we had to disable the scroll bar outside of the component every time we use it. We want the modal component to be something we can drop into a project with minimal hassle. We'll start by updating the modal component file in the editor. As I said before, we'll allow the developer to enable or disable the scrolling behavior. We'll add a prop to the component for allowing them to do so. Yet, we want the prop to be optional. We'll update the props option to an object instead of an array. We'll add a prop called show. We'll make it a required prop because we'll still need to know when to show the modal. Next, we'll add a prop called scrollable. In the options, we'll set the default property to false. If this property is true, the user will be able to scroll around the page. A falsy value will mean scrolling is disabled. The next thing we'll do is check the scrollable property when the modal appears. We can watch the show property to check when the modal is opened. We'll add the watch option to the component. In this option, we'll watch the show prop where we'll accept the new value. Inside the function, we'll create a conditional statement to check if the new value argument is true. This will mean the modal is visible. We'll add onto this statement by also checking if the scrollable property is false. If both checks pass, we'll disable the scroll bar. Here's the problem. We want to disable the scrolling behavior on the entire page, but we're in the component. How do we disable the scroll behavior from the component? We'll do what we did last time. We'll manipulate the document. We aren't going to bind any classes or styles on elements. We can directly mutate the document to achieve what we want. Inside the block, we'll call the document.body.style.setProperty function. This function will allow us to add a CSS property to the document. The arguments for the function are the property and value, respectively. We'll set the overflow property to hidden. The scroll bar will be removed when the modal is visible. We'll want to add it back when the modal is closed. We'll add an else block to the function. In the else block, we'll call the document.body.style.removeProperty function. This function will remove a CSS property from an element. We'll remove the overflow property from the body tag. We're done. Let's try testing the modal. In the browser, try opening the modal. The modal opens and the scroll bar disappears. This is exactly what we wanted. It's the default behavior of the component. If we close the modal, the scroll bar comes back. Let's try testing if the scroll bar sticks around when we set the scrollable prop to true. Switch to the app component file in your editor. In the template, we'll bind the scrollable prop on the modal component to true. Let's go back to the browser to check the behavior. This time around, we'll be able to scroll around the page. It's perfect. Well, almost. There's one last problem we'll need to fix before we can consider this complete. First, let's look at the issue. Back in the app component, we're going to set the open data property to true. Next, we'll remove the scrollable prop from the modal component in the template. Let's head back to the browser to test the app. Because we're setting the show data property to true, The modal will become visible on the initial page load. The modal is working, but the scroll bar is still around. This shouldn't be the case since we removed the scrollable prop from the component. The default behavior is to remove the scroll bar. So what is going on? View doesn't run watcher functions when a component is created. It runs them whenever the properties it's watching changes. This behavior is a problem because the show prop is initially set to true. The watcher function will never run when a property is initially set. We can fix this by changing how we write watchers. Back in the modal component, we're going to update our watcher. We can set watchers to objects instead of functions. We'll add the show property to the watcher option. It'll be set to an object. In this object, we can configure the watcher further. We can set a property called immediate to true. This property will tell View to run the watcher function when it's initially set. We can add the function by using the handler option. This option will be set to a function with the new value accepted in. We'll cut and paste the code we previously had for the function in the handler function, and we'll remove the show function. Let's head to the browser to test the app. The modal is opened without the scroll bar as we wanted. We were able to manipulate the scroll behavior from the component. The main takeaway from this should be encapsulating the behavior in the component. We didn't have to make adjustments to the parent component to get this working. The modal component doesn't interfere with external components. It's completely reusable and flexible. Before I end this lecture, I'm going to set the open data property in the app component back to false. In this lecture, we're going to look at one of the newest features introduced in Vue called the teleport component. Teleporting is a design pattern for moving an element from one location to another while still keeping the hierarchy of components intact. Teleporting was introduced to make it easier to structure a project without using Vuex or emitting events through multiple components. We'll look at the problem teleport's address before we get into them. For this example, we'll be working with the modal component we had last time. We'll remove the paragraph tags from the app component because we don't need them anymore. We know that scrolling can be enabled or disabled. Currently, the way we're opening the modal is by listening for the click event on the button. This event will toggle the open property to true. The changes are then communicated to the modal component. It's a very simple setup. In larger apps, this doesn't scale well. In most cases, you'll likely want to open a component from a child component instead of the app component. We kind of saw an example of this when we worked on the music application. The authentication modal was opened from the header component and not from the app component. Let's try opening the modal from a child component to visualize this better. In the components directory, create a file called action.vue. We'll scaffold the template and script blocks for the component. The name of the component will be called AppAction. From the app component, we'll cut the div tag surrounding the button. We'll paste this into the action component's template block. In this scenario, we're going to pretend we have a child component that will open the modal. The job of the action component is to tell our application to open the modal when its button is clicked. Typically, you may want to do this when the user performs an action such as clicking a link or submitting a form. Since we moved the button into a child component, we won't have access to the open data property. We'll emit an event from the child component for the parent component to listen to when the modal is opened. On the button, we'll change the value for the event listener to call a function called openModal. In the options, we'll add the methods object where we'll define the openModal function. From the function, we'll call the this.emit function to emit an event called open. Back in the app component, we'll need to import the action component. Next, we'll add the components option to register the action component. Up in the template, we'll load the action component where we previously cut the button. Lastly, we'll listen for the open event on the action component. If it's triggered, we'll update the open property to true. We'll get the same behavior we had last time. Let's go to the browser to test if the modal still works. Clicking on the button will result in the modal opening. Everything seems great, so what's the problem? Conceptually, this is what our application looks like. The app component is the parent component to the modal and action components. It holds the open data property, which it sends down to both components. The action component emits an event telling the app component to update the open data property to true. A simple representation of what's going on in our app. The problem with this approach is it doesn't scale. Let's imagine we have another component called contact form. It houses the action component where it's still responsible for opening the modal. This will mean the data will need to be passed down and emitted twice. This problem gets even worse if we add more layers. The way the components are structured is very disconnected from one another. One solution to this problem is to use Vuex. It works great because we don't have to worry about communication between components. However, it should only be used for global state. If we add state to the store, we'll probably need to add actions, getters, and mutations as well. This can clutter the application store. It makes sense to use the store if various components can open the modal we're creating. If the modal is going to be opened by a single component, storing its state in Vuex isn't the best approach. Well, what is the best way to approach this then? In a perfect world, the modal component will sit as the child component to the component that's responsible for toggling its visibility. With this approach, we don't have to pass down data continuously through layers of components. Events don't need to be emitted in a chain. The store stays clutter-free. It makes sense to structure a project like this. If we have a component that needs to open a modal, the modal should be the child of the component toggling its visibility. In this case, the action component should be the parent of the modal component. It doesn't matter how complex the architecture of our application is. As long as the modal component is the child component to the component toggling it, our code remains simple and manageable. The job of the app component is to load the action component. It doesn't need to store the data or listen to events. There's one problem with structuring the app like this. Let's look at what that is. We'll restructure our app to look like what we saw in the previous slide. In the app component, we're going to move the registration of the modal component to the action component. First, we'll move the import statement. Next, we'll remove the modal component in the components option. Afterward, we'll go back to the action component to add the components option. We'll register the modal component there. We can begin to load the component. We'll go back to the app component to cut the usage of the modal component from the template. We'll switch to the action component to paste the usage in the template. Since the modal is being loaded in from the action component, we'll need to store the state of its visibility. In the app component, we'll completely cut the data function and paste it into the action component. The click event in the template can be updated to set the open data property to true. We can remove the methods option from the action component altogether. We don't need to emit an event anymore. Lastly, in the app component, we don't need to pass down data or listen for an event on the action component. We can remove these bindings from the component. Let's try testing this application in the browser. The modal will still work even though it's nested inside the action component. This is because modals usually have a fixed positioning. The positioning allows us to freely place the modal anywhere in the application. However, we're not entirely free from the parent component. Let's go back to the editor to find out why. Back in the action component, we'll apply a style attribute to the root element. We'll set the opacity property to 0.5. Back in the browser, we'll see that the button is semi-transparent. The button's appearance is something we might want to have. If we click on the button, the modal will appear semi-transparent as well. This is the problem with loading the modal as a child component of the action component. Here's the visualization again. It's better to structure things like this because we'll know exactly what's toggling the modal's visibility. The problem is that the styles affect the modal. This can result in an unexpected appearance. This problem can be fixed with Vue's latest feature called teleports. A teleport will take an element from one location and move it elsewhere. This will change how the document looks, but without having to restructure our app differently. Let's look at how this works. The best place to load the component without external styles interfering with its appearance is at the root. The body element is the container for the overall application. It's the perfect place to load a modal. In the action component, we'll wrap the modal component with the teleport component. The teleport component has one property called to. The value for this must be a query selector of the element we'd like to move the component to. We'll set this to body. The contents of the teleport component will be moved to the root of the document. In the index.html file, we have such an element. The component will get loaded in this location. Let's check the browser to see if this works. The button will remain semi-transparent. If we click on it, the modal will appear. It's still functional, and it's not being affected by the styles of the parent component. It's fully opaque. We can use the developer tools to see what's going on. Under the Elements panel, we'll find the modals element. Initially, we left it empty. Peeking inside, we'll find the modal component. It's been moved from one location to another. We can look inside our app to find the modal is no longer where we placed it. This is the power of the teleport design pattern. The modal is functioning because it still accepts the props from the parent. It can continue emitting events that the parent component can listen to. We didn't have to make changes to the component to get this working. It can still be used the same way we used it before. Let's switch over to the Vue developer tools to view the hierarchy of components. The modal component is still a child of the action component. Vue will keep intact the relationship between components even though they've moved. The teleport component was introduced to address the problem of keeping component relationships closer together without them affecting each other visually. You don't have to use teleports, but they can make your code much more organized. One last thing I want to note is that we can teleport multiple elements to a single element. We don't have to create multiple locations for every new modal we create. We can continue using this one location to load all our modals.